You guys are right on course, so I'm talking about my evening class. What's this? Why isn't this working? Oh. Okay. Now, a little bit of review. Now it decides to work. The Pythagorean theorem, c squared equals a squared plus b squared. Hopefully all of you are familiar with that. Now, what I'm doing right here with this page is I'm drawing an analogy for you. Today we're going over the distance formula. Now, in the Pythagorean theorem, you know fixed distances A, B, and C. Okay? You know, or at least you know two of the three. In this case, we're presuming you know the height and the length of a right triangle, and then this C would be the hypotenuse or the long side, the side opposite the right angle. Okay. Now, if we tried to solve for C, this length right here, we would have to take the square root of both sides or minus. Now, when we're dealing with distance, we only use the positive side because distance is only positive. You can't measure negative distance. Okay, so that's why we're only using the positive side here. Now, let's look at this. C equals a squared plus b squared. Well, what is that? It's this side squared and that side squared. And then you take the square root of those to get this. Let's look at the distance formula. If I have a couple of points, like right here and right there, okay? And I want to know the length of this diagonal line. Well, it's easy to find this and it's easy to find that, okay? Notice here, I started at 1, 1. Up here, I had 1, 4. I don't have this on the y-axis, in this case, on purpose. But basically, we have, and I also started one space above the x-axis. So I didn't want this on the axes because that would throw some zeros into my formula, and I don't want those yet. But if I look here, I have a distance of 3 between the point 1, 1 and the point 1, 4. I have an increase of 3 places in the y direction. Do you see that? 4 minus 1 gives me the 3. In the x direction, I have from x is 5 to x is 1. So I have an increase of 4. Same values I have here. Now, in this, we just put the 3 and the 4 in there, square them, multiply them out, take the square root of both of them, and get the length of the side of the diagonal. In the distance formula, I've got these 2 points, these 2 endpoints on this diagonal line. So I've got x2 and x1. If I subtract those, this value, that's x value, and that x value, I'm going to have 5 minus 1, which ultimately gives me 4 again. Okay? And then I've got to square it like I did over here. For the y values, I'm going to find the difference in the y's, how much change in y value there is. And doing that, 1 minus 4 is -3, and -3 squared is the same thing as +3 squared, but to make this one technically correct, I would have to have this in there. Okay. But that still gives me 16 plus 9, gives me 25, gives me a distance of 5 units. Now, we can't count 5 units here because this graph paper and those are going diagonally, so they're not just 1 unit increments. Okay? So that's what we're doing here. Do you see the parallels between this distance formula and the Pythagorean theorem? The only difference is the distance formula is the Pythagorean theorem, only conducted to use with coordinate values. That's the only difference. Okay? So, that being said, now let's go on to some other problems. Okay, here is the distance formula. You should have this, I believe, on handout 30 in your packet. That's the page with all the different formulas on it. Okay, that's the main page of formulas for this class. Here we show the change in the x value plus the change in the y value squared equals the total length of this, whatever this line is. Now we'll go to something with numbers in it. Okay, here we go. Now, does it matter which one you call point 1 and point 2? No, we had that discussion before. Okay, we've had that discussion that it doesn't matter. I typically like to call it point 2, so we can just go left, right with the x and the y values. So I typically call it point 2 on front. But in this case, since I've got them labeled, we've got to go with what it is. So this one is point 2 and that one is point 1. Because that's what they are in reality. Okay, so where did I get this plus from? Well, if these are the x values, I'm going to go +3 minus -3. This was minus a negative, which is why that's highlighted as a positive. Same thing over here. It would be 0 minus -4. Well, 3 plus 3 is 6 squared. 4 squared. 6 squared is 36 plus 16 makes 52. $52 breaks down into 4 times 13. Ever heard of the game 52 card pickup? Yeah? Did you bring your test down? Here, thank you. Okay, so anyway, that's where this 2 came from, is we extracted this 4. Okay, so I've got 2 radical 13. And here at this point, because you are needing to be able to have a physical measure, we have to convert that radical into a square root. There's where your calculator comes in handy. Okay, anybody need me to show you how to do that in your Casio calculator? I'd like to see it. Okay, What you're wanting to do is you're wanting to take 2 times square root of, in this case, 13. That's the nice thing about this Casio calculator, is what you see is what you get. Okay, it goes in there just like that. Then you hit the equal key, and at first it does that, but see this S equals D, standard equals decimal. So there's your 7.21. Now, anytime you round off a decimal value, you got to use the approximately symbol instead of the equal symbol. Okay? It's a 1-point deduction if you forget that. So let me get this out of the way. We've got that. I can put my calculator away. We'll see if I need it anymore. Maybe I will, maybe I won't. Okay, any questions on this one? Okay, another one. And the distance between these. This one you may want to use the calculator, you may not. You may not. Find the exact distance and approximation to 2 decimal places. Well, actually, I am going to use the calculator on this one, just to show you how nice of a calculator this Casio happens to be. So I'm going to clear this thing. So I need to put all of that stuff in here. So I'm going to take the square root of parentheses. Then I'm going to put in this. Okay. Now, 2 ways you can do it. You can put this number in parentheses and have minus a negative, or you can just simply change it to a plus yourself. I'm going to change it to the plus myself. So I've got 3.8, close the parentheses, and I am going to square it. I hit the X square button. Plus, parentheses again, 1.5 minus 4.5 close the parentheses and square it. Doesn't that look exactly what we got up here? Except it's kind of scrolling off the end.
You forgot to put the 1.2 in after the 3.8.
Say again?
You forgot to put the 1.2 in after the 3.8.
I did? Well, let's go back and see. Let's just go. Yeah, I did, didn't I? Thank you. That would have made a bit of a difference. Okay, we got plus 1.2. Now it should work out right. Okay, and I'm going to hit the equal key. You see, it does come to the square root of 34. Now, if you make a mistake and you put all this into your calculator without writing any of that down, you would get 0 points. Okay? Because I've got to have justification for me to give partial points. Put your calculator away. Put your phone away. Now, I want to see this. And I want to see that. Yeah, you can do that. Okay. You could just put it in right here to be a little faster. I mean, 8 and 2 is 10, 3 and 1 is 4, total of 5. The arithmetic is not that hard. Square root of 34 absolutely is a 17 times 2. Neither one of those numbers are a perfect square. So here you put in the 5.83. To get that, over here I have to hit the SD button. And you see you get the 721. Okay. So actually I went backwards, didn't I? I need to go forwards here to that one. There.
Why is that a negative 3?
Where? Where?
Under the second.
Here?
Yeah. Why is that negative 3?
Because that's a negative there, and 4.5 is bigger than 1.5.
Gotcha.
So it comes out negative 3.0. Okay. But squared, it doesn't matter. This becomes 25, that becomes 9. 9 plus 25 is 34. Okay. All right, where do I lay my pointer down? Oh, there it is on that black where I couldn't see it. It was camouflaged. Here's another one, more complicated still. Now we have radicals inside radicals. And by the way, the calculator will work this one too. You would just type in 6, radical symbol 3, get out of that, parentheses, square, similar to what we did last time. But in this case, these have exactly the same variable components, because remember, radicals and variables behave the same way. Okay? So I can combine these two into 5 radical 3. These two, I have the same radical component. There's a hidden 1 there. So I get just simply radical 6. I square radical 6 and I get 6. I square 5 radical 3 and I get 25 times 3. This didn't show that. 25 times 3 from 5 squared and radical 3 squared. These two give me square root of 81, which of course is a perfect square, so we can use the equal sign this time. Okay, you guys do this one. If you don't have a calculator with you, you can bring it down to the simplest radical form. 2 times 29 makes this, but you know what? 2 and 29, either one are a perfect square. Put this in here. Equals 10 point it does not equal, it approximates 10.77. Okay, let's think about this. Perfect squares. 100 is a perfect square, it would give you 10. 11 squared is 121. That's one of those numbers you were supposed to kind of get to know. So the answer of this is somewhere between 10 squared and 11 squared. Hence that. Okay, any questions on this one? Anyone not ready for me to erase? Okay. A little bit of geometry. Here are 3 points on a triangle. This is asking, are these a right triangle? Well, let's plot them. Actually, right here's the right angle. And that's the hypotenuse. Okay. Now, how can we prove that that is accurately a right angle? Well, we can use the Pythagorean theorem. If the distance of this length from A to C is equal to the square root of this one squared and that distance squared, then it would truly be a right angle. Okay, there's the quadratic formula. Okay, the distance between points A and B. That's what we're doing right now. Okay, in this case, point A and point B, we get square root of 32. Now, there's no particular benefit in us taking this down right now, because this is an exact value. A decimal is a rounded off value, and there would be some round off error somewhere. Okay, now let's look at the distance between A and C. Okay, for those of you who don't remember, let's go back and look how this thing was labeled. A and C is the hypotenuse. A and B is this thing, which if I rotated the whole picture around, that would be the typically the length. Anyway, and then that would be if you rotated it around. But anyway, here is the hypotenuse. So that's the one we've got to care about being equal to the square of these two, the square root of the squares. Okay, so we've got those two. We've got the hypotenuse. We've got one of the legs. Now we do the other leg. And we get that. So, using the quadratic formula, we take this one squared plus that one squared better equal this one squared. Okay, here's your C squared, B squared, A squared. Well, root, you get 32, you square root, you get 18, you square root, you get 50, 32 plus 18 do equal 50. Therefore, that truly is a right triangle. Okay. Kind of had to go around this one in almost a backwards way. And yes, it is. Okay, now we're moving on to our second skill of the day, finding the midpoint of an item. Okay, you got a line, you got endpoints on this line segment. Somewhere there's a point halfway in between. Now, let's look at these two formulas. I'm going to throw out a question just straight up before I do any explanation. I told you I don't do that anymore since my experience with conjugates, but I'm going to do it this time. What do these two individual pieces of that resemble? Any ideas? Yeah? No, not really. I'm not squaring anything and I'm adding instead of subtracting. How do you average two numbers? Don't you add them together and divide them by 2? I'm adding the two x values together from the 2 points, and I am dividing them by 2 to get my halfway x point or value. Then I'm adding the two y values together and dividing them by 2 to get my halfway y point. Well, here's kind of an illustration on that. Let's go to some numbers. I got these 2 points. I want to find the point halfway between them. I just arbitrarily number them 1 and 2. By the way, this is the only formula where you're using that x2 and y2 business, or x2 and x1 and y2 and y1 that you add instead of subtracting. This is the only one where you're adding because you're averaging them. Okay, well here we add the two x values together and we're going to divide it by 2. When you do that, you end up with 135. This taken away from that because of signs is going to give you 2.70, and then we're going to divide that by 2 to get 1.35. (15 minus 8 is 7). So these two together. Okay, or 70 if you want a 0 behind it. Over here, you get 4 divided by 2, -2. Now, all this is putting this in fractional form. You have 1 and 35 over 100. 35 over 100 reduces to 7 over 20. Okay. And 20 over 20 for the 1. Over here, it's just 2 over 1, -2 over 1, or just simply -2. What they're saying is if you had a drawing of this, and unfortunately I don't, that point would be halfway, the midpoint. Okay, here's one more. In this case, here's our 2 points. I numbered them 1 and 2 that way. I averaged the 2 x values and the 2 y values. I simplified them. Okay. So anyway, here's my point after I simplified that fraction. -3, 1, 2, -1, 2. -5, 7, 1, 2, 3, 4, 5, and up 7, 1, 2, 3, 4, 5, 6, 7. There's the number. If I graph that point, -3/2, okay, that's the same thing as -1.5, right? So over 1.5, and now up 2. Well, doesn't look very good here, but at any rate, it should graph out exactly if you had graph paper instead of my approximations. Oh, well. Anything hard about midpoint formula? Just remember, it's the only one where you add stuff. Okay? Because you're averaging. Circles. Whoops, let's put that definitions back up here. I don't know if you need to write this down or not. Circle is a set of all points in a plane that are same distance from a fixed point called the center. The fixed distance from any point on the center to the circle is called the radius. Okay, so the radius is half the diameter. Diameter is all the way across through the center. Radius is just from the center to the outside of the circle. You know how important circles are? In both the Middle East and South America, they built pyramids. They were aligned with the sun. How did they do that? I mean, they didn't have fancy calculators and stuff. How did they do that? Well, they came out here and they drove a stake in the ground. And then they got a rope, however long it happened to be. Okay. If it was a cubit, it was the distance from the wrist to the elbow. You might have heard that in a biblical story about some boat being 300 cubits. Well, it could be a farthing, which is based on the length of a horse's back. Or it could be hands, which is based on the height of a horse based in hand measurements. Or it could have been whatever measurement units they used at the time. Could have been just some stick. Okay, they used knots in the Navy. Well, anyway, they got this rope. And it was, let's call it that long. I don't know how long it is. And then they drew a circle around that. And a little long on this end, but we'll pretend that's a circle and that's the center. Okay. Now, they made this circle by just simply keeping the rope tight and going all the way around. That's called the circumference. This, of course, is called the radius. Diameter would be all the way across. Well, the next thing they did, in fact, was the diameter all the way across. Then they drew another diameter through that center that's at a right angle to that one. And there are the sides of your four-sided pyramid. And that's how they did it. Pretty creative, right? And what we would like to think is a primitive society. Okay, well, let's go on. This is a formula you got to memorize. You must memorize, actually, all three formulas I've given today, you must memorize them. They will be on the final. That's not it's a promise. And you need to know how to use them backwards or forwards and so forth. Okay, what in the heck does this business mean? Well, see this H and K right here? Instead of x of 2 minus x of 1 and y sub 2 minus y sub 1, they've got h minus k, y minus k. It's kind of similar, and those are in turn squared. Okay? This thing is kind of like our distance formula. Okay? If I put a radical over this, and what's the square root of r squared r? It would be kind of like d equals that stuff. So this formula is a little bit the same, except we don't have the radicals on it. Now, h and k are the coordinates of the center point of the circle, where they drove that stake in the ground. Now, r stands for the radius, and it has to be bigger than 0. That's why we don't use a plus or minus, because the distance can only be measured positively. Okay? So using this formula then, we can write the formula or the equation of a circle if we know the center and if we know the radius. For example, here's the center of a circle. We know that it has a radius of 4 units. So now what we need to do is we need to find the equation of that circle. First thing I want you to do is I want you to write that h minus k, or x minus h and y minus k equal r squared. I want you to write that formula first. Just get in the habit of it. Then you do your substitutions. Does that sound like the way we've done some things in the past? Write the basic formula, write the substitutions. Now you work it. Okay? Well, in this case, that's as far as we need to go. By the way, where'd that 16 come from?
4 squared.
4 squared. Yeah, 4 squared. Here's the x value. Now, why is that a plus? Because you were subtracting -3. Okay? Here, you're just subtracting a +2. So a way we can think of this to make it easy where we don't have to think is just look at this and put in their opposite signs. You see that? That minus is in the x minus h, y minus k. We'll just make the opposite signs in both cases. So that's just a quick and easy way for filling that in. Here's that center point, -3, 2. And I'm telling you how to do this in Algebra right now. First, you plot the center point. The radius was 4. So from that center point, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You go that many in the perpendicular directions. Then you just draw the loop. Okay, now let me give you a hint in Alex to save you some grief and time. When you get ready to plot these points on your graph, you have a little button up on the side of the screen somewhere that says magnify. Magnify this so you can see to plot that point accurately. Otherwise, using your mouse, that's what you're using, or a scribe if you're lucky, you might be off just a little. And if you're off just a little, it'll graph it off just a little and then it'll count you wrong. So magnify before you plot points in ALEX ever. Okay. Questions about this? Whoops. Let's back up. There you go. There's your circle. That one's better than if I had tried to draw it. Because I tend to make the bottom of my loops a little elongated when I do that. Okay. All right. Here's another one. You write this equation. And then you make a rough graph of it. Hopefully you've got that. Of course, there are no signs on zeros. You could add a plus there just as easily. But here you notice you got opposite sign, and then we got to square that radius. So here is this equation simplifies. This equation simplifies. And I need to point this out. If I square this binomial, I just get x squared because 0 is nothing. And I'm just squaring the x. But if we're going the other way, if I give you this equation and you have to find those two values, if you just have something like this, that means that the center point part of this is 0. If it doesn't have a following. Okay? So if it doesn't have a following, whether it's an x or a y, that means that that part is 0 of the center. Okay, now we got to graph this thing, and there it is. Hopefully all of you came pretty close on that. Okay, another one. Here's my formula. Notice opposite signs. Squared. We get ready to graph it, and there it is. These circles are really pretty easy, aren't they? Provided one thing. You know that formula. If you don't know that formula, you're in a heap of trouble. Well, here's some of my nasty scribbles on an uneven backboard, a wiggly backboard. X minus h, there's the basic formula. Opposite signs. Okay. 4 squared. Here's the center. Over 4, down 4, left 4, up 4, draw the circle. Identical to all the others. Now, this one's got a little geometry in it you may not be familiar with. Anyone know what the word tangent from trigonometry means? Okay. Tangent means it's at a right angle to something. Okay. So if I read this statement up here, the center of a circle and the circle is tangent to the y-axis. That means I've got this line of the y-axis here, and this circle with its radius to the center is at a right angle to the y-axis. That also implies, but does not say, that the circle touches the y-axis as one of its points. Okay? So, in this case, it says the center is 0.32. Well, 1, 2, 3, and down 1, 2, right there. Let me put it in. Okay. Now, if this radius right here has to be at a right angle to that one and just touching it, okay, that means that this must be the length of the radius, in this case 3. So go over 3, go up 3, go down 3, draw the circle. Now then, applications of this. Have any of you heard when they were talking about space vehicles, capsules, shuttles, whatever, that they reach a certain spot, and if their velocity is too great, they will go skipping off into space? Stories about like that. That point where their speed has to be such where they can come on down, or they keep on going, is the tangent point. Okay. Now, they also talked about this in the movie Hidden Figures, if any of you have ever seen that. Remember, they had to invent the new math, which turned out to actually be old math, to convert from an elliptical orbit to a parabolic orbit, a parabola, from going in an ellipse to, from this point, making a parabola to land. Well, that tangent point was up here, okay, where they had to be just right so they'd fall off some, but not continue in the orbit or go into deep space. That's where this comes to reality, okay? And sometimes, maybe I'm not going to do it today, but I've got a picture in the movie Hidden Figures, you know, that huge blackboard they had that people were up on ladders. I've got a picture of the real one, because I happened to have been in Houston in the 60s on a field trip that I was in for engineering from my university, happened to be Oklahoma State at the time, although I finished at KU, different story. But I saw that. I've ridden in their centrifuge. Lost my cookies. It was ugly. Fortunately, not in it, but soon after. They really get irritated if you throw up in the centrifuge, because then somebody's got to clean it up. Anyway, let's continue. I want to get some stuff done. Okay, our radius was 3. So now we have enough information to write the equation. Okay, opposite sign, radius squared. There's the equation of that circle, which is tangent to the y-axis, meaning touching, and the radius is at a right angle. And their circle's a little bigger than mine. Okay, here's another one. Uh-oh, this time I gave you the diameter of a circle. I tell you the radius. So we can take one of these points on the end and the midpoint of that for the center. Does that make sense? Okay. So anyway, here is my midpoint formula using those two, and I get the point -2, 1 right there. But I still don't know the radius, so I can't find the formula. So I got to find the distance from the midpoint to one of the two endpoints. So that's what I'm doing here. Here's my -2 and 1 from the midpoint, and here's my endpoint values, the -1, -1. And I simplify and square this. I get square root of 5, which according to the calculator is 2.236, approximately. Now, I'm not actually going to use that approximation. I'm going to use this because it is exact. And there's one thing one step I left out on this. This is that squared. That's where that 5 came from. Okay, because the radius has to be squared. So anyway, here is my value. So that means that these distances are 2.236. Questions on this one? Sometimes they don't throw it to you straight up. You very well could have a problem like this on the final. You very well could have a problem like this on my exam too, where you have to take some multiple steps and use multiple ideas. Okay, you can go. Okay, this right here, you notice I've got that spot up here. We don't have to do this, but you can. You can multiply this out and you can multiply that out and combine like terms, and it'll end up like that kind of every time. This is in general form. This is in standard form, and you can be doing it by factoring or something called completing the square, which we are not required to do any longer, fortunately, because it's a pain in the rear. Okay, here's a problem. Oh, that. If you square that, you get this. If you square that, you get this. If you bring down the 25, put it on the other side. And here's that general form. You notice we have all unique variable content. Okay. Is this worth much of anything? Not really. Okay. Not really. Now, I'll just put that up there. Remember, the radius has to be a positive number. That's all that this is saying. Okay. What if the radius squared is 0? Then it's just a single point, because a radius has no length. So it's just a single point. That's what this is saying. Okay. What if the radius is a negative number? No solution, because that would force you to have square root of a negative number would be imaginary. Okay, and we couldn't graph it. So you can't have negative radius squares. Okay, now I give you this equation. You've got to tell me the center and the radius. Well, opposite. So far, real easy, right? Square root of that. So far, still easy. Now, based on this information, we graph it. Done. Pretty easy. Like I said, these can go either way. I can give you these points and you have to find that, or I can give you that and you have to find these. Okay, now we're going into the last element for today's actual assignment. We are on schedule, and although this is on today's, I need enough time to go over your test. So we're going to push this back to Wednesday, and I still should get the entire week completed on Wednesday. That's my plan.